Welcome. All right, so let's talk for a little bit about running times here. So different algorithms, right? So for instance, like sorting and different algorithms might have different time complexity on different data sets, right? So you might remember, for example, that in insertion sort, right, that if your set of data in your array is almost sorted, then the time complexity is it's about linear, right? But if it's almost backwards, right, then, and in fact, if it is backwards, then it's the worst case and it has to rearrange the data the most and it ends up being quadratic runtime, right? So when we're analyzing algorithms, we often care more about the worst case than about anything else, right? Because we want to know really what the worst scenario is, right? But we can also, care about things like best case and average case. So for example, let me just skip ahead here for a second. So maybe we have a whole bunch of different inputs, and again, like maybe these are different types of arrays, right? So we have some of them where if we were going to measure the runtime for each one, right? If on this array it runs, sorting takes 5 seconds or 5 milliseconds, but on this array, hey, it's more sorted, whatever, it only takes 3 milliseconds, and so on. Right, I get a pretty good feel here for what the best case instance is and what the worst case instances are, right? And then the average case, right? And of course, average is a little bit harder to do because you actually need to add up all the runtimes and then divide by the number of instances. In this case, it'd be pretty simple, but sometimes it's really hard to figure out even what all the potential inputs are. So average is usually a little bit harder for people to do. Right. So let's go back to our question here. So worst case, we usually focus on worst case then for two reasons. One is it's usually easier to compute than the average. And second, because it really matters, right? So let's consider a couple cases. This link right here goes to an article that talks about this. So the tail, right? So the longer cases. So what do we care about? So they talk about Google, for example, and imagine that if you could think about the time that it takes to run a Google search, right? Maybe most of the time it comes back effectively instantaneously. They have some pretty good measures for what people would expect for seeing that first page of hits. But what if every so often it took Google 7 seconds to come up with the first page of hits? That's like, they'd go out of business, right? I mean, there's just no way people would settle for that given the stiff competition. So the worst case runtime is what matters to them, right? Think about some other cases. Right? So one that I like to talk about is and it's kind of a morbid example, but think about air traffic control. Right, so here, maybe planes have, sometimes they take a little bit shorter, a little bit longer, depending on weather conditions and so on. And so they want to schedule all the arrival times of the planes. Imagine if they didn't factor in the worst case times, right? On average, the planes don't hit each other. All right, plane here, they go on their merry way. Right, but in the worst case, not so much. Yikes. Okay, you can imagine, right? Death and dying ensue, and not very good at all. Right, so they need to handle the worst case. They need to plan for that worst case. Well, the same thing is going to be true for our algorithms. Most of the time, what we're analyzing is worst case complexity, right, rather than average case. Right, and again, let's go back to our example here. Right, so we talked about the runtime for adding elements to an array, right? We talked about it earlier, right? So in the array list, say when we double, right? So we have to do every so often we have to grow the array. We'd have some time that it takes to copy, and then no additional time. Then we're copying. Then we do no additional work. Then we copy a whole bunch of elements, and so on. So every once in a while. So the worst case here is this linear case, right? On average, if you want to think about this even geometrically, these guys sort of, if I think about the areas of all these guys kind of falling into here, let me get this picture down here. So averaged over time, sure, not too much. It's just going to be amortized constant time per operation. But it's still worst case O of n. And again, if the application area that you're pursuing where the worst case matters, right? Then you might not want to use an array. All right, say you have some example where you just have streaming data that's coming in fast and furious, and if you don't store it, it gets lost, right? So an array may not be the best thing, the best structure for you to use unless you have some other way of dealing with it. Okay. Again, what I want to say here, since we're talking about average, amortized is a type of average, right? But average case, we're generally talking about inputs, like different kinds of arrays. How long does it take a sort? For instance, amortized, which is average over time. I'm doing a bunch of inserts into an array list, and some inserts take more, not because of the value of the item that I am inserting, that doesn't matter, but over how many inserts I've done before it. Okay. All right, that's it for this. I'll see you back next time.